A categorical variable, or called quantitative variable, refers to a characteristic that cannot be quantifiable. Categorical variables can be either nominal or ordinal. A nominal variable is one that describes a name, label, or category without natural order. The characteristic for urban is a nominal variable. Next, an ordinal variable is a variable whose values are defined by an order relation between the different categories. The characteristic for the Sherlock is an ordinal variable. Numerical variable or quantitative variable is a quantifiable characteristic whose values are numbers except numbers which are codes standing out for categories. Numerical variable can be classified into two types, which are discrete and continuous. Discrete data represent items that can be counted. The characteristic for income and advertising is this discrete data. Meanwhile, the characteristic for each is continuous data. Continuous data represent measurements that can be possible value, cannot be counted, and can only described by using intervals on the real number line.
Hello and Assalamualaikum everyone. My name is Nizana Suha. Now, I want to present central tendency for set D. To calculate mean, we must divide total fx by total f. Mean for income is 68.61. For advertising is 7.44 and mean for age is 53.43. This is mode. To calculate mode, we must first identify lower class boundary or LM and difference between frequency of model class and before and after frequency of model class and size class or C. Mode for income is 67.42 and mode advertising is 2.51 and for age is 59.28. Next, to calculate median, we must identify lower boundary class, frequency of median class or FM, cumulative frequency before median class or FM minus 1, and class size. Median income is 68.83, advertising is 5.53, and age is 54.5. The measure of position for quartile 1 or N per 4. We must first identify lower class boundary of quartile class, cumulative frequency before quartile class, frequency of quartile class and class size. Quartile 1 for income is 43.42, for advertising is 2.17 and for age is 39.27. And for quartile 3, format is same with quartile 1 but not N per 4 but 3N per 4. Quartile 3 is for income is 90.78, advertising is 12.16 and age is 66.38. Measure of variation. Sample variance for income is 778.88 and sample standard deviation for income is 27.91. Sample variance for advertising is 36.84 and sample standard deviation is 6.07. Next, sample variance for age is 264.51 and sample standard deviation is 16.26.
Hi, good morning everyone. My name is Jessica. In slide, I'm going to explain about the graph that we get data after using the software. For the advertising graph, as we can see, for axis X increase, meanwhile axis Y decrease until the second bar, and increase on the third bar and decrease again until the sixth bar. For the A graph, as we can see, all the value is increased. Next, for income graph, as we can see, if the axis X increase, axis Y also increase. This is pie chart for the two datasets, urban and Sherlock. For the urban, they have a two categorical, yes and no. Meanwhile, Sherlock, they have a three categorical, good, medium, and bad.
For the 4.1 numerical descriptive measures, so this is the statistic from the SPSS software. When we're using the SPSS software, all the data of mean, median and mode are different between using the hand calculation. From the chapter 4 that we have learned before, to make the calculation is more accurate like a calculate mean, median or mode, the SPSS software use the ungrouped data, same like the original data, while the hand calculation is grouped data. For the histogram, the graphical representation that there is no differences about histogram by using the SPSS software or hand calculation. This is because the data such as numbers that used in hand calculation and SPSS software are the same to create this histogram.
Hypothesis testing. We use t-test that run by SPSS software for hypothesis testing. From t-test, we can interpret that 95% confidence interval of mean difference of income does include 0. P-value is not significant because p-value is higher than 0.05. Therefore, we cannot reject null hypothesis. In conclusion of the t-test, at the 5% level of significance, that the mean of income are different between yes and no. Income of yes is higher than no. Correlation analysis. We use SPSS software to run the analysis. From the analysis, we found that the p-value for the correlation coefficient was 0.45, which is greater than the significant level of 0.05. Therefore, we cannot conclude that there is a statistically significant correlation between income and urban, which is R equals to 0.4 and P more than 0.001.
Confidence interval. We use SPSS statistics software to find the related confidence interval. Then we conclude that the 95% confidence interval of no income lies between 61.61 and 72.43. Then the 95% confidence interval of with income lies between 66.15 and 72.54. Prediction modeling. We use SPSS software to construct a regression model. For instance, based on the sample data set, we can do y equal to 21 plus 11x1 plus 67x2. Here, y can be the number of income, x1 can be the number of advertising, and x2 can be the number of age.
At the end of this project, with the data set that I have given, we can carry out the statistical calculation and make a report of analysis between hand calculation and software. We have calculated measure of frequency, central tendency, which mean, median, and mode. The measure of position for quartile 1 and quartile 3, and measure of variation standard deviation using a hand calculations. We also use software to assist us with calculations. Even so, we find out that the final answer for each hand calculation is different with software calculation answer. Every descriptive measure on hand calculation, the answer is slightly different with what in the software. This is made because of the software using a different algorithm for calculating the answer. There are a lot of ways to calculate mathematical problems, and the software calculation produces the slightly different result with the formula that hand calculation use. Other than that, we also did hypothesis testing to compare the difference in mean between no and yes. There is also correlation analysis aimed for measure the strength of the relationship between urban and income. Next is confidence interval in two variables for urban and income. Confidence interval is calculated from a sample statistic and the standard error of the statistic. Last but not least, prediction modeling is method that uses historical data to predict future income. In conclusion, after finishing this project, we believe that utilizing software to gather data is more accurate and quicker than handwriting. If done by hand, it will take a long time to finish because of formula must be used to calculate the data. Because there is a greater likelihood of recording mistakes, missing number or over-numbering while using handwriting, the program will aid in the verification of data inaccuracies. Software can also be updated and programmed depending on the situation. This will assist us in resolving a variety of data issues that call for the calculation of intricate formula when handwritten. This program will make the process of calculating the data quick and easy. This shows that software is very necessary in solving data to maintain accuracy and reduce the data error.